What are the most important skill sets for an ML engineer? Well, I asked ML engineers at all these companies to share what they consider the top skills. And I'm telling you, there were a lot of answers I received, and I bet you didn't even think of many of them. So in this video, I want to share the 7 most important skill sets you might need to know if you want to become an ML engineer. Let's start with the simpler ones and get to the increasingly more important ones. What is the first skill that comes to your mind when you think of software engineering? Knowing a programming language will very likely have crossed your mind. This is the most obvious and fundamental skill you really need to have. But the question might be, which programming language should you learn? Well, some of the ML engineers I asked said it really doesn't matter, because once you know one, you can learn any other, but the vast majority straight up said you need to know Python. That said, you might still be asking yourself, well, okay, how much do I actually need to know? And the answer here quite often is not so much, really. Don't get hung up on knowing the ins and outs of Python. As long as you know the data types and basic data structures, you should be good to go. The more you work on projects, the more you will learn. But most of that knowledge will not be Python specific, but more general software engineering knowledge. But still, the recommendation is, in pretty much all cases, Python. Okay, so you want to become an ML engineer, right? Well, one of the scariest questions you might have asked yourself is, how much math will I really need? And when I asked the ML engineers, they mostly agreed on this point. You will most likely need some understanding of calculus to understand gradient descent, or probability theory to understand some of the lingo used to describe ML models. But you will hardly ever do math yourself. It's mostly to get a sense of how things work under the hood. So in most cases, the basics are really enough. In my previous videos, when I talk about math for machine learning, I pretty much always say the math you need for ML is not that difficult. Of course, the more you know, the better you will be as an engineer and will be able to work on more research-related teams. So, in short, basics of calculus, linear algebra, and probability theory are important for understanding the fundamental ML algorithms, but you don't need complex stuff. Yet again, there is no denying that it would enormously expand your capabilities. There really is much more to ML engineering than just writing code. So let's look at a skill set that is rarely ever explicitly taught to you at college or in other online courses. Let's have a look at some soft skills. And as you might have noticed, this skill set comes after Python and math, so is arguably even more important than those two skills. As an ML engineer, you are a software engineer, which I try to make a bit clearer in my video explaining the different ML jobs. So you will be tinkering a lot and writing scrappy code to simply get it to work in the first place. You will very likely need to spend a lot of time trying to fix one annoying problem, and can very quickly get frustrated. Being a good ML engineer requires patience. ML engineers that rush through problems without taking the time to really fix and understand them will only create more problems. You don't want to be that guy. You want to really understand what you're doing and be able to properly present and explain it to others. Another issue that every ML engineer will face is the rapid speed of progress and the new developments that appear pretty much every week. To remain valuable as an ML engineer, you need to know what the latest developments are, and this will involve reading papers, taking online courses or lectures, reading blog posts, and probably even listening to high-quality ML podcasts. All this requires commitment, willingness, and joy in leveraging every opportunity to learn something new. And the underlying skill, or rather personality trait, that allows you to be a great, up-to-date ML engineer is curiosity. You need to, more often than not at least, want to know what the latest developments are, to be able to talk with your colleagues about them and potentially directly implement them into your current project. You need to want to watch new lectures and courses created by professionals that will give you an edge over those that don't. Pretty much all of the ML engineers I asked, and know on a more personal level, regularly watch lectures and take courses to learn new skills that will set them apart from others. We'll get to those skills later, but for example, one that is very important is knowing how to write hardware-accelerated code and how distributed computing works. And from whom is it better to learn those skills than from the people who actually build this hardware, which is used for pretty much every ML engineering job out there. You probably guessed it, I'm speaking of NVIDIA and their Deep Learning Institute's self-paced courses. That is why I'm very happy to have them sponsor this video, because their courses are of so high quality and made for learning machine learning engineering skills that are relevant to the real world. They have amazing, practical, self-paced courses on a variety of topics, such as the just discussed accelerated computing, but also more fundamental ones on deep learning and generative AI and LLMs. Everything is in one place and made for people who really want to become ML engineers in industry. And a great deal of these courses are available for free, including the ones for the very beginners, like Generative AI Explained. One course that I can really recommend is the course on Fundamentals of Accelerated Computing with CUDA Python. And as a beginner, you can also start with an even easier introduction to CUDA, again for free. And if you want to explore generative AI even more, they have a really in-depth course on text-to-image diffusion models. So if you're interested in learning real ML engineering skills, click on my link in the description below and explore the amazing courses NVIDIA has to offer. Okay, I myself love taking such courses and know how important patience, grit, and curiosity are. But the issue still is, these soft skills are often overlooked because they don't have an obvious ROI, return on investment, such as writing hundreds of lines of code or learning a new library every week, which gets us to the next skill set. You know, seemingly small skills make a huge difference. Let me explain. The majority of ML engineering involves handling a handful of core ML developer stack libraries, and you might be surprised what many of these top ML engineers I asked had to say about them. Firstly, you don't need to know every library that exists and switch to new ones once they are released. Learning how to use libraries like NumPy, Pandas, and Matplotlib will be crucial. But learning them doesn't have to be overwhelming. Some 5-minute beginner tutorial, let's say on Pandas, covers so much. You will never need to know every single function of any of these libraries. As long as you know how to generally use them, you will be able to search for the functions you need on Stack Overflow or leverage an AI coding assistant. The important thing is what you do with these libraries. Matplotlib and Seaborn, for example, are simple plotting tools, but it is much more important to know how to approach data visualization. This means you need to know how to properly convey the underlying information or insights you can gain from those plots to others. Data visualization was a skill that was mentioned more than once in my survey. Even if there is a simple X% improvement in some ML metrics, you need to be able to translate it for normies. And honestly, you understand your results even better when trying to explain them to others. If you cannot explain something to beginners, you probably don't understand it well enough yourself. Now, of course, besides these libraries, you will want to learn how to develop simple, classical ML models with scikit-learn, which will be used for more ML engineering roles than you might imagine. Nevertheless, you will still want to learn a more hardcore ML framework, such as TensorFlow, PyTorch, or even JAX. It doesn't really matter which one you choose, because if you know one, you will be able to learn another one, but I personally recommend PyTorch because that is the one that is growing the fastest, has the strongest community, and most modern educational resources leverage PyTorch. This all might already be enough, you might think, but what some of the ML engineers I asked also mentioned is to learn a bit more about CUDA and CUDA-related libraries. The more comfortable you are with the widespread skills, the more you want to differentiate yourself with skills and knowledge that are not that common, but very useful for many ML engineering jobs. Be it because you might actively use those skills, or because you will have a much better intuition of how things work under the hood, and can therefore make better decisions for optimizing code. Now, before we continue to add more and more skills that are arguably even more important, I want to make clear that you don't need all skills at once to get your first job or internship. You can very much land a normal software engineering job or internship and later transition to ML engineering. These skills will come over time. You will learn different skills working on different projects or watching different kinds of lectures and courses, which will undoubtedly make you a better and better ML engineer. But as long as you have fun and really are committed, you will invest the time in one way or another, and you will learn most of these skills. You know what? Why not? You could also use this video to write down all these skills and keep them as a rough guide and checklist to what you still want to learn and where you already are. So I'm sorry for being this boring, but this is just important to me to make it clear it will take time, but is a lot of fun. Now let's finally continue to the next, increasingly more important skills. Yes, the question on machine learning and deep learning knowledge. Let's see what the ML engineers I asked had to say about that. Interestingly, some of them didn't even specifically address the skills of ML knowledge, which shows once more that 1. There are a lot of different areas you can work in as an ML engineer, some requiring very little knowledge of ML algorithms, and some more. And 2. That the main skills they highlighted are again software engineering skills. That said, many of the ML engineers said you do need to have a good understanding of the classical ML and deep learning algorithms. But you don't necessarily need to be able to come up with the derivation steps of, for example, the support vector machine objective or elbow loss. Depending, of course, on the role, but since we are talking about ML engineering here, it is very unlikely. Again, you still need to understand the algorithms and probably wants to prepare a bit more when going into tech interviews. Now, the more important thing is that you need to have a good breadth of all the algorithms, knowing which exists and their advantages and disadvantages, so that you can then look them up when you actually need them. Even more important is that you need an understanding of ML best practices and tricks for improving model accuracy, for example, regularization techniques, or efficiency tricks like quantization, and have a good understanding of all the different hyperparameters different models have and their effects. As an ML engineer, working with the ML models themselves in one way or another, which is not always the case, it is even more important to have this intrinsic curiosity about the new developments in the field and, again, more of a broad overview. As mentioned, ML is moving so rapidly nowadays that it is very important to somehow remain up to date with the latest advancements. It requires reading potentially dozens of papers, sometimes trying out open source code, and so on. And yes, you have heard me right. Even as an ML engineer, you need to be reading papers, and you sometimes might need to be determined enough in the situations where you don't feel like reading a paper and curiosity fades. But you still are an engineer. You need to try things out. For example, trying out open source code, running things in a Jupyter notebook or Colab, and looking at code other people have written. And there are many different domains you at some point might want to specialize more towards, for example, computer vision for industrial applications or recommender systems, but generative AI is undoubtedly one of the hottest things to learn at the moment, and it's moving fast. More or less over the course of a few weeks, RAG, Retrieval Augmented Generation, became a thing, and every ML engineer working on Gen AI applications needed to learn what RAG is and how to properly apply it in their pipeline. Those state-of-the-art things you simply learn through reading papers, blog posts, and taking very up-to-date courses or webinars. But there is one more very specific skill when it comes to working with machine learning, which is often overlooked, but is a huge part of real-world ML engineering, and was mentioned so much by the ML engineers I asked, so let's have a look at that skill set next. So usually most aspiring ML engineers, especially beginners, look at the loss, and perhaps one metric I might think, cool, loss goes down, some number goes up, and perhaps my model is better than another one. And then get back to spending most of their time tinkering on the training pipeline. At least that's how I was for a long time. But if you look at the distribution of how many of the professional ML engineers I asked mentioned the importance of model evaluation, you will see that the model eval is arguably even more important than the training. I mean, I get it. Who cares about your trained model if its evaluation is simply false or misaligned with what you actually want to achieve with the model. It is even quite common to have ML engineering teams focused only on the evaluation pipeline, designing the metrics, building the benchmark datasets, and making sure that the quality of the benchmark is the best it can be and aligned with the goal the model is supposed to achieve. Knowing how to verify model quality involves deliberate experimental design and analysis. You need to know how to change one tiny variable in a system and measure its effect on performance. And performance can be measured on many different axes, not only model accuracy on one certain benchmark and metric, but also, for example, memory efficiency, training speed, inference speed, and many other company internal metrics. You need to understand what certain metrics measure and what the benchmark you're using is designed to evaluate. It's not all just simple classification accuracy, and even there, having a high simple classification accuracy on the test set does not mean it will perform well in practice if the test set is not representative of the real-world setting you want to deploy the system in. In fact, in industry, you will often not necessarily want to use the academic benchmarks, but create your own ones from your own real-world and business-related data. And as already mentioned, you will need to know how to properly track, visualize, and explain all these findings. There is much more to evaluation than you might think, and it is arguably a much more important part of ML engineering than the training loop itself. And it might surprise you, but there is one more thing that is also more important than the actual training logic, which we'll get to in the final, most important skill set: the fundamental software engineering skills you need. This is the last time I say it, I promise. ML engineers are mostly software engineers. This means you will need to know the basics, such as data structures and algorithms, but also something that might not be that obvious. But back to DSA, as with normal software engineering jobs, you will rarely really need to implement a binary tree from scratch from memory, but you will very likely still need these skills to pass the coding interview. Another core software engineering skill is to know how to approach normal system design and now also ML system design problems, which are often similar, but with the latter having an ML model as a core part that needs to be properly designed, incorporated, and maintained. Okay, and what about the actual coding skills? Well, I have mentioned this in another video, but writing code is not coding. Debugging is coding, and is a crucial skill for ML engineers as well. You are not wasting time when trying to find an annoying bug that will probably just be a one-liner, or when going through potentially bad documentation of libraries and code, or even having to debug your deployed model on Linux using something like Docker. This will be a large part of the work you do, and a skill you need to constantly improve. The better your intuition gets to where to look for the problem, the better and faster you get at debugging. I know those are general software engineering skills, but one software engineering skill that is more specific, or rather common for ML engineering, is data engineering. Again, I mentioned that model evaluation is more important than the actual training pipeline of the ML model. Well, data engineering is apparently often also much more important. Not only is it infeasible to train a ML model without data in the first place, but a lot of the model improvement actually comes from better data. In rare cases, there are whole teams responsible solely for data engineering, but in most cases, data engineering falls into the category of what you might need to do as an ML engineer. Being aware of data quality, data contamination, how to properly filter data, and knowing how to get the most out of little data are very important skills that are often overlooked because they might not be as flashy as starting a new model training. But the software engineering skill that was mentioned the most by the ML engineers I asked was knowing how to implement distributed systems and hardware-optimized pipelines. This is especially relevant nowadays when wanting to work in generative AI. These systems are trained across multiple GPUs, multiple nodes, and even multiple data centers. Knowing how the data is being moved around to the diverse computing environment, and an understanding of performance capabilities, relationships, and limitations of related components, think of GPUs, CPUs, interconnect, and networking are such important skills to have. And learning those skills from practical, up-to-date online courses will probably be the best bet if you don't know how to figure it out on your own. Which could be tricky, because you see, after learning the basics of machine learning and software engineering, there is no clear roadmap to follow. You just need to keep moving and learning, and everything will make more and more sense and fall into place. This list of skills will hopefully be a good guide to what you might want to learn, but you will likely struggle a lot, even when learning the basics, such as the math for machine learning. That's why you might want to watch this video next. I there share the secrets that made learning machine learning much easier for me. So happy learning and bye bye!